Yo, what up? It's Billy C. Lemons in his house. Yeah, this beach ball. It's not really a beach ball, it's a yoga ball. It has a lot of volume, as you can tell by how big it is. But it is not very massive because it's not that heavy. Bounces back up. No, it's not heavy. And yeah, the weight's not that big either because I can obviously pick it up with ease, one hand. You know, look at that. Yeah, so. And this baseball volume is very small, but its weight is also very small because I can move it easily, and its mass is also small because I can move it easy. Okay, so compared to this yoga ball, this baseball has a lot of mass, a lot more mass, and it has a lot more weight, but it's also smaller than it, so that means the volume is smaller.
I'm going to define three things: mass, volume, and weight. The mass of an object is how much inertia it has, whereas the volume of the object is how much space it takes up. The weight of an object is how much gravity acts on the object. Newton's first law is an object in motion will stay in motion, and an object in rest will stay at rest unless an unbalanced force acts on it. In other words, you don't need force to have motion. However, you need force to change motion. An object will only accelerate if a net force is acting on it.
An example of Newton's first law of motion is if you have a fire truck with the ladder on top. If the ladder is totally secured to the truck, if the truck is moving down the road, the ladder is moving with it. So as the truck is accelerating, the ladder is accelerating with it. If the truck is moving at a constant speed, the ladder is moving at a constant speed. If the ladder is not tightly secured to the truck were to get into an accident, the ladder would move in the direction that it was before the truck was in the accident.
When riding a skateboard, if one hits the curb, the person on top of the skateboard will repel forward because any object in motion will remain in motion unless an unbalanced force acts on it. In this case, the unbalanced force is the sidewalk, and once the skateboard hits the sidewalk, it will stop, and your body will keep moving because there is no unbalanced force acting on it.
An example of Newton's first law in everyday life would be, say you have a coffee in your car, and you are accelerating. The coffee will want to stay where it is. While you are accelerating, the coffee is going to want to stay where it is. So that's why the coffee will spill all over your lap. The reverse will happen if you brake. So say you're going forward at a constant velocity, then all of a sudden you come to a stop. The coffee is going to go all towards the front of the car, all over your steering wheel and on the floor. The reason why my face stopped this boot was because my face is the unbalanced force.
An object at rest has to stay at rest until an object in motion has to stay in motion until an unbalanced force acts on it, like Billy's head. The reason that the banana slid down the knife was because the banana and the knife were both originally in motion, but then the knife came in contact with the table, which was an unbalanced force that acted upon it and stopped the knife, but didn't stop the banana, so the banana continued in the motion that it was in and slid down the knife. This shows that Newton's first law shows that an object in motion stays in motion until an unbalanced force acts upon it. If the mass of a car was doubled, how much longer would the stopping distance of it be? The answer is that the stopping distance would also double because the mass has doubled and they are directly proportional. If an elephant is chasing you, why is it better to zigzag rather than just run in a straight path? Okay, the answer is because the elephant has more inertia than you. Therefore, you can change direction quickly, whereas the elephant cannot.
If you're in outer space and you happen to come across some aliens and you want to battle them and you only have a cannonball, how much force would need to make that cannonball keep moving after you shot it? The answer is none. So that's examples of Newton's laws in everyday life.